Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by Techstrong and Gremlin. My name is Cody J. Brown. I'm the host of Techstrong Learning. We have an exciting presentation ahead, but first I have just a couple of housekeeping notes to cover. First, today's session is being recorded. So if you miss any of our discussion or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session. If you have any questions, we do want you to send those in using the Q&A tab, which can be found on the right side of your screen. That's also where you're going to find the chat tab, and this is where we want you to engage with us, engage with your fellow audience members. Just let us know your thoughts or where you're tuning in from. And finally, before we close, we will give out 4 $25 Amazon gift cards, so be sure to stick around till the very end. So our topic today is getting started with chaos engineering, and I'm joined by Aomi Richmond, Reliability Specialist at Gremlin, and Don Darwin, Senior Solutions Architect at Gremlin. Aomi, Don, thank you both so much for joining me here today. I'm going to let you take it away.
Awesome. Thanks so much, Cody. So who here remembers this outage? It affected a lot of people, and it all started when an engineer intended to cycle some S3 billing machines, and a CLI command took down numerous critical machines. This impacted orgs like Docker Hub, GitHub, Travis CI, Slack, PagerDuty, all applications that allow us to build and deploy our apps and services and connect with our teams went down, and a lot of teams saw issues. People weren't getting the proper alerts, and AWS couldn't even update their own status page. Similarly, in 2019, my Office 365, experienced 2 outages, one on January 24th and another on January 29th, where millions of users were affected. Outlook as part of the Office was down, so customers couldn't receive or send emails for over 12 hours, and a lot of businesses closed for the day. Similarly, Google also experienced an outage in 2019, and it had some cascading effects, like Nest thermostats going down. Imagine working in a cold house because Google was down. And even things like iCloud were affected. Again, this led to users not being able to receive or send emails. They couldn't access docs or other files, and it led to a lot of businesses having to close down for the day. And I'm bringing all this up not to kind of poke fun at these giants, but to really show that failures are everywhere. If you pick a date, search for outage, you're going to find something. And this is, again, all to say that failures are inherent to complex systems. But, what do I mean by saying complex systems? With the shift from on-prem to the cloud, there are some good things that came out of it, like decreased costs, lower maintenance, a better ability to scale. But with the result of that, we had less control, and we needed new ways to build applications. And this led from the shift from monoliths to microservices, because the cloud is designed for these smaller compute resources, but a larger number of them. This ultimately led to decoupling teams and increased developer velocity, and again, the better ability to scale. But we have now tens and hundreds and thousands of microservices in these environments, and a larger and more distributed and inherently more complex environment. With this, we need new ways to test and handle failures. The image on the screen you can see are these quote-unquote death balls from Amazon and Netflix, and this is from 2015, so you can only imagine what they look like today. And when we test, we want to test for downtime in these failures, and downtimes cost money. Some of the quantifiable costs associated with this is revenue. You can find this if you talk to the accounting or the sales teams. Employee productivity, customer chargebacks. There's also unquantifiable costs like brand defamation. Customers don't want to use broken products. And to be honest, sometimes you can quantify this if you look at things like stock price. So I believe in 2017, British Airways actually had an outage, and they lost about $75 trillion in stock overnight. Another unquantifiable cost is employee attrition. People don't want to work at places that are on fire. And this leads to a very vicious cycle. When there's less people to handle incidents, there's more burnout and more employee attrition. IHS Markit reports that $700 billion is lost annually to downtime. When you work at a giant like Amazon Retail, this amounts to about $220,000 per minute. On average, downtime costs $300,000 per hour. So if we do a little bit of math, there's 8,760 hours in a year with 3 nines of availability, or 99.9%. That equates to about 8.76 hours of downtime per year and an annual loss of $2.63 million. So failure is inherent and it costs a lot of money, as we just figured out. What should we do? My answer is chaos engineering. Chaos engineering helps to identify weaknesses so you can build more resilient systems and hopefully avoid some incidents. And if an incident does occur, it trains you to identify those incidents and to respond correctly as a team. So before we dive into chaos engineering, a little bit about me. My name, as Cody mentioned, is Yumi Richmond. I'm a reliability specialist here at Gremlin. I've been here for a little under a year now. A fun fact, I'm getting my pilot's license, so if anyone wants to talk aviation, I'm all ears. And my email and my LinkedIn are on the screen, so if you want to connect afterwards with any questions, I'm always happy to. So, we'd love to see how many people have heard of Gremlin. So as I mentioned, obviously I work at Gremlin, and we're a company focused on helping you build more reliable and resilient software and processes. So to do this, we built a chaos engineering and reliability platform so you can safely inject failure into your systems to learn from it. We do have a free trial, and it's on that URL on screen, but I'll post it at the end as well. So chaos engineering, what is it? To jump back in history a bit, chaos engineering is not new. It's very fundamental to humans to have that curiosity and want to try risky things to see what will happen. A little bit prior to 2010, an engineer by the name of Jesse Robin manually was wreaking havoc in data centers by pulling power cords. By 2010, we saw many enterprises actually beginning to form disaster recovery teams. A Netflix engineering tools team created Chaos Monkey to help them facilitate Netflix moving from on-prem to the cloud. By 2014, Bruce Wong coins the term chaos engineering while working at Netflix, and we see that the wider industry begins adopting chaos engineering and moving from reactive to proactive reliability. In 2016, that leads us to where we are here today, with Gremlin being founded by Colton Andrus and Matthew Forniciari to really help companies safely and easily practice chaos engineering. The chaos in chaos engineering is a bit of a misnomer. We're really just simulating the chaos of the real world in a controlled environment. Introducing chaos is methodical and scientific. We like to follow the scientific process here, so we start with a hypothesis and experiment to validate that hypothesis. You want to start with the smallest increment that will yield a signal and move safely from small scale to large scale tests, and move safely from dev to staging to production. Like all other things in life, communication is vital here, so you want to share your plans with everyone. What if there is an incident? You don't want this to negatively affect other teams, and you always want to share what you learn. Chaos engineering is all about learning, and sharing what you learn makes everyone better engineers. And when I say share, don't just share internally, share externally as well. We have a chaos engineering Slack that's a great online resource, and engineers are constantly talking about different chaos experiments that they're running and kind of what their findings are from there. Lastly, chaos engineering is all about iteration. So you want to create a hypothesis, run your experiment, create tasks to improve your software and then your processes, and then you want to update and repeat. Then you want to increase your blast radius and keep repeating experiments. And then eventually you want to automate it, like everything in engineering. And when you automate, it helps to prevent you from regressing. So to sum it up, chaos engineering is thoughtful and planned. It helps you reveal weaknesses in your systems, both technical and human. And some questions to ask for, your technical systems, see where it's broken or insufficient, like your user experience breaking. Is your monitoring and alerting set to the correct threshold? Is your auto scaling working? For the human side of things, where are human systems ill-equipped, or where are processes broken? How does our alert rotation look? Our documentation and playbooks, our escalation processes. So hopefully, if I did my job correctly, you should be convinced that chaos engineering is exactly what you need. But typically we hear some people have some excuses on why they're not ready to start now. The first one being, we don't have time for this. Our daily operations are a time suck. We're always reactively firefighting. And something that I've heard in the past is everyone has the same amount of time. It's what you choose to prioritize during that time that really dictates your success. So what's more important than making sure your business is up and available? Another excuse we hear often is that things break on their own. And that's true, things do break on their own, but they also break on their own time, like at 3 a.m. when you're asleep, or on the weekend when you're trying to enjoy your time with your family. So wouldn't you rather have things break on your own time, like when you're sitting in a room with your team at 3 p.m. and everyone has a fresh cup of coffee in front of them? Lastly, we hear that we don't know where to start. And the answer is simple. You want to start simple. Is your system's resilient to CPU pressure, to memory pressure? Does your service restart if the process or container is killed? And then you build from there. What are some assumptions you have about your system? And then validate them. So that's it. No more excuses. Now is the time to start. And when I say now is the time to start, now is the best time to start. And this is because, as we saw, systems become more complex over time. So it's best to start when things are as less complex as possible. So how do you get started? Again, you want to start small and be careful. You want to start out by targeting a single service or host and not the whole application or fleet. You want to do this in a controlled environment, again, with your team at the ready, and then expand from there. Build your comfort and then, build the experiments from there. You want to adopt the practice in development so engineers are actually architecting for this failure. As you get confident testing and development, then move to staging. Then again, start small in staging, expand your blast radius, and finally move to production. Start small and increase. This is really similar to how you do development, so don't overthink it. Work iteratively like with code, move up the environments like with code. You should already know how to do this. And this is all to say, no two environments are the same. No matter how close your staging is to production, it's not production. So unless you're testing in production, there's no guarantee your recovery safeguards will function. And I know testing in production sounds scary, but that's where a lot of our customers live currently. So in addition to starting small and in development, your tests should progress as well. So we like to start with our resource failures. What if there's a spike in CPU, in disk, memory, I/O? This is what the cloud is built for, so you want to make sure that your auto-scaling is working. From there, we go to service failures, like process killers, shutting down host pods, containers, and skewing clocks. You want to ask yourself, can my service restart itself without any manual intervention? Is traffic automatically routed to the restarted service? If I'm moving from a different availability zone or region, you want to make sure everything is resilient. Next, we like to move to dependency failures, so dropping network traffic, changing DNS, increasing latency, and packet loss. What happens if a dependency is unavailable? What happens when the network is bad? Can my service handle things asynchronously? We then move to application failures. Once our infrastructure issues are in order, you want to move up the stack to test at the application level. You want to inject latency into the code and throw errors. See if there's proper monitoring, logging, if there's proper timeouts and retries. And from there, again, we want to automate it and have continuous chaos. Once you have confidence in resiliency to particular failure mode, you want to automate it to prevent drift into failure and any human errors. So this is all great in theory, but does it actually work? One of our customers, Backcountry, who's a retailer in outdoor goods and equipment, had a 72-hour SLO breach on Black Friday back in 2017. They had issues writing to a database that stored orders, and this caused the shipping warehouse robots to misship orders during this time. So after Black Friday, their engineering team thought they had a fix, but they couldn't verify it. And it's very hard to create a staging environment of a warehouse with robots. So they couldn't run the issue in an environment, and they had to run it in production. So they looked to Gremlin, installed us in their production environment, and ran a game day or a large-scale experiment. They're able to verify the fix and in turn also identify other latent bugs. As a result, the pickers did not misship any orders despite introduced latency, and their Black Friday 2018 went off without an incident. Another one of our customers is Mailchimp. They provide a service that sends out emails, and they have a great customer experience with many services that contribute to that. So they wanted to verify what services were included in their critical path. The critical path is the set of services which are required for a customer to have a good experience. They started off by black holing or dropping network traffic to a service that they believed was not in the critical path, causing a 503 or service unavailable error. And it took down their entire application and pages across the entire web app. Since the service was deemed to only be providing nice to have information, it was actually eventually removed from the critical call path, and the auxiliary information was only used to enhance the customer experience, not dictate it. This is all to kind of say also that in a microservices architecture, it's important to limit points of failure to only those that are necessary. So no matter what your business is, your customers rely on you for a good experience. These are a handful of the companies that we currently work with today, and you might recognize some of the names. You might be able to see some similarities in your companies and theirs. Each of them have found value in proactively testing for failures, no matter what industry, no matter how big or small. So that kind of concludes my portion of it. I'll throw this slide back up on the screen at the end so you can get the link to that free trial, but I'll go ahead and pass it over to Dawn to take over for the demo.
Great, thanks, Ayumi. And thanks everyone for joining us today. So I'll give you a brief introduction to chaos engineering using the Gremlin platform and three design principles that differentiate the Gremlin solution from other practices that you might see in the industry are that the platform is designed to be simple, secure, and safe. And I'll start out the demonstration by focusing on that first principle, simplicity, and show you how Gremlin is easy to use, set up, and recover from experimentation. I'm going to do that using a simple retail banking simulation application from Google called Bank of Anthos. And it's a microservices architecture that's built around a web front end. We actually have a load generator running on the front of that web front end, but that's where the users interface with. And then that front end uses services on the back end for authenticating and creating users, the user service, APIs for managing contacts, and then APIs for capturing transactions and reporting transactions, the ledger writer and the transaction history, and a balance reader for reporting the balance. And consistent with what we typically do, as Ayumi pointed out during her presentation, we start out small, and we often attack dependencies, look for resiliency in the systems by disabling dependencies. And we're going to start out here by taking one of the services, the balance reader, one of the APIs, down temporarily, and testing a theory, our hypothesis that the system is resilient to the loss of any of these back-end services, and it will have minimal impact on the user experience. I'm going to do that, but before I do, first introduce you to the web application itself. This is that Bank of Anthos application. And you can see it has some basic functionality here. It's got the balance in the upper left here being fed by the balance reader service. That's the service that we're going to impact during the demo here. It has the transaction history reported below, and then we have functionality for making deposits and sending payments. Again, very oversimplified site, but we'll impact that. We'll test our first scenario using the Gremlin user interface. It's important to note that Gremlin, although has a robust web interface, Gremlin is built around a REST API, or a rich set of APIs. We refer to it as an API-first solution. And that means that for most of our customers, the execution of chaos engineering is really done through automation, through the application lifecycle, often through integration and execution through their CI/CD pipeline. But for the purposes of this demonstration, we'll use the UI to make it easy to follow. I'm going to do that using a Gremlin experiment. We call them scenarios. And you'll see here first that the Gremlin scenario, first of all, has a hypothesis that describes what we expect to happen and our expectation for the way that the system will react. And here we know that the balance reader service, when unavailable, we expect will have no negative impact on the functionality of the site. The way that this experiment is built, or what the key components to it are first of all, a status check. So the status check is an automated test upfront to ensure that a condition is being met. In this case here, I'm going to test my website to make sure that it's up and responding, and that it responds with an appropriate response code, and that it takes less than a half second to respond. That tells me that the application, the system, is in a functional ready state, and that my experiment will be valid. The other component to this is the actual attack. So when we talk about executing an experiment, a chaos engineering experiment, the attack is that unit of work. It's the failure condition that we're going to introduce. In this case here, what we call a black hole, which is a temporary network block of communication to a service or a host or other piece of infrastructure, to make it appear that it's not available by temporarily blocking the communication. This, in this case here, for 10 minutes across all instances. It's going to make the balance reader service unavailable, unreachable for that period of time, to simulate what would happen when that service is down. Now, I'm going to run that directly from the user interface, and this could easily be done through a REST API call. But before I do, I want to highlight the one point about this is that when we execute this, we're not actually attacking the infrastructure directly. There's no way that you can communicate into a Gremlin client that's available for running attacks, because there's no point of ingress into the system. That's part of the security design of Gremlin. All attacks, all communication is registered in the control plane, and the clients regularly check into the control plane using an authenticated connection to look for work to be done. And in this case here, I'm going to run the scenario. It will register the experiment and then wait for the client to check in. So I'm going to do that right now. I'm going to run the scenario, and this is going to activate the experiment. You'll see here that it's staging the request here. And the first thing it does is it runs my validation check, my status check. And we'll see here that the site passed, and so the test can continue. There was a brief delay, and now it's activating the black hole, which is currently in a pending state. What that means is it's waiting for the client to check in to pick up these instructions. And when the client picks that up, it will distribute it locally and enable the attack, the temporary black hole of communication. And once that's done, it will go into a running state, at which point this experiment is up and active. We can see here now that it's running, and I can be running these tests in conjunction with my load testing tools. But in this case here, I'm going to do it through the browser. So I'm going to refresh my page. And we can see, first of all, the response time is a little slow. This is usually a very crisp site. But immediately, I can see the impact of the experiment in the loss of the balance here. But the site seems to be up and working. Now, I would say that this is probably not ideal. This would impact the user experience because they're uncertain about the balance, and we should handle this better. There should be some kind of messaging or caching of the balance, so we can make note of that. But continuing on in my functional testing of the site, I can see that the transaction history is still working, and I'm just going to make sure that I can still deposit money into my account. And again, the response time seems a bit slow, but that worked. And then I'm going to test the last piece of functionality, which is to see if I can send a payment to one of my contacts. And that will be the final validation piece that the site is okay. And I can see here that there's an unhandled exception. Right now, the payment service has failed because it can't reach the balance reader. So this refutes my hypothesis. This disproves the theory that the site is resilient to the loss of the balance reader because I've lost a piece of functionality. And worst case is it's a poorly handled exception. So one thing I want to do is probably capture a screenshot of that error. And yeah, let me make sure I capture it correctly. And also, at this point, my testing is complete. Now, the test is going to continue because I've run this experiment for 10 minutes. But I've already finished the testing. I've identified the weakness in the system. And now I need to, first of all, terminate the experiment. And you'll notice that I have the ability through the UI to halt the experiment or halt any experiment that's going on. That's part of the safety feature of Gremlin. You have full control to terminate or stop any experiment, any attack that's at any point in time. And additionally, there's a built-in mechanism that if anything should happen that blocks the client communication to the control plane, all experiments will be shut down, all attacks will be terminated. And that prevents you from being left in an unstable state. So at this point here, I've completed the experiment, and the first thing it's going to ask me when I halt it is to document some initial findings. It's going to ask, did your system perform as expected? No, I don't think it did. I think I uncovered a potential incident here. I'm going to document that here in my Q&A. Was it mitigated? No. But then I want to add the notes in here to describe the failure. I can say that the payment service fails, without the balance reader. Probably want to make note of the missing balance needs, messaging or handling. And I also want to make note of the response time increase. And at that point, I've taken some initial documentation of the results. So I have a complete lifecycle run here. I can add additional documentation into the results from my experiment, including adding things like my screenshot that I captured at the end there. And then I can also send this incident create an issue in Jira to assign this to somebody else on my development team or part of the part of my peer team here. And I don't even know who my teammates are here. And maybe add some additional notes in here about failed balance reader test. And at this point, I'm got a JIRA ticket created from this. The development team can begin working on this. And the last thing that I want to point out is that at the completion of this, once the attack is halted, I can refresh my page and you'll see that everything was restored to its previous state. So Gremlin allows you to dynamically enable these failure conditions and run the experiments for a period of time. It will restore everything back to its previous state. It allows you to do that simply and also in a secure way so that no one can actually it can initiate attacks through direct communication with the client, and also safely. That there are mechanisms to allow you to control and halt any experiments that are running, and also to an automatic mechanism to terminate any experiments that might occur if communication is lost between the control plane and the client. So at this point, my demonstration is complete. I hope you learned some things about chaos engineering and Gremlin, and I'll turn it back over to for Q&A.
So looking through those questions, I'll just start from the top. So when thinking about chaos engineering, how do you know where to start? And what experiments do you run on a first service?
Yeah, I think. Oh, you got it, Don.
Yeah, there are definitely a finite set of attacks that typically, in fact, there's even a tutorial that's published about Gremlin and the your first attacks that you should run. But there are some basic attacks that you should always start with. Basic resource attacks, things like testing your services for CPU and memory tolerance, and also dependency testing to, just like we showed there, is your system tolerant to the loss of any one or more backend services, databases, or downstream services? And you can do that easily through what we call the network black hole attack. So certainly resource attacks, network black hole attacks are really good starting points. And again, take a look at online for Gremlin tutorials for the 5 attacks you should start with.
So what are some chaos engineering experiments that you've run at Gremlin?
Well, as we've just described, the basic attack types for Gremlin are pretty straightforward, easy to use, and they are things like CPU, memory, and disk exhaustion or resource consumption, as well as what happens when a block channel device like a disk becomes busy. We call that an IO attack. There are very common attacks for state, things like shutting down a server and killing processes. And then there's a special one from Gremlin called time travel that is used to simulate what happens with time-based failures. What happens if a certificate expires? And this can be done through changing the dates on your servers or your hosts. And then, of course, the network ones are very popular. The black hole that we just described there previously, there is the DNS failure, which is similar in that it simulates what happens when you lose communication with a DNS server. There are latency attacks. Latency attacks are very popular. They simulate what happens when you have slowdown in communication to or from services. And then there's one for simulating what happens when a network is unreliable, and it's called packet loss, and does random packet failure or dropping. So those are the ones that we commonly use and are available from the product.
So are you able to stop an active experiment or failure once it has started, or do you have to wait until it's completed?
No, absolutely. As we showed during the demonstration, that halt button or halt all buttons are immediate. They have immediate impact on any running experiment, and you don't have to wait. The agents themselves will restore the environment back to its previous state immediately when the halt is issued.
So, at the completion of a failure or experiment, do we need to manually restore our systems to return them to how they were before the failure?
No, the design of the Gremlin solution, especially when we talk about simplicity, is that the value of the fact that the Gremlin solution will restore things back to the previous state. In the case of killing a process, that might be something where you need some kind of external or manual restoration, but all other attack types will automatically recover themselves.
Great. So this next question reads, how do you recommend approaching testing in production?
Many of our customers do test in production, and they do it for a wide variety of reasons. They might be doing it because there's no duplicate for production. They don't have similar systems that they can test. Many customers will do it for compliance reasons. They need to regularly show that they're testing their production systems for resiliency. And sometimes it's for testing the readiness of SRE and DevOps teams to handle problems. But usually you start early in the application lifecycle, testing and using chaos engineering early in the life cycle, and then doing it automatically as you promote the application through the different stages, and gain a good, solid comfort and understanding of how your systems respond. And after you've gone through that process of starting small, starting early, and learning how chaos engineering works, then is when you're most comfortable doing it in production. So again, shift left, and then promote through the application lifecycle.
So from a security point of view, would a hacker be able to take control of your agent and run attacks against your servers?
No, really great question. No, there's no communication port. There's no point of ingress into the Gremlin client. So you cannot communicate with it or pass it commands to execute.
So next question reads, can I use Gremlin in Kubernetes, and is there a lab or a course that you would recommend?
Yes and yes. It is designed to work in Kubernetes, really containerized environments, Kubernetes, or in VMs and hosts. You can use it across all those different environments. It's built we have our own Helm chart to easily deploy the Gremlin solution into Kubernetes with a single command. And sorry, I forgot the last part of that question.
Any courses or labs you would recommend?
Yeah, so there's a wealth of tutorials that are available on the Gremlin, gremlin.com under our resources section there for common experiments to run and guide you through using the different attack types on different infrastructure. Also, Gremlin regularly conducts every month boot camps that allow you hands-on experience to practice and learn chaos engineering, and much like we just went through in the demo today.
So how is this different than traditional testing?
It's proactive. The typical testing or typical solutions today are more about monitoring and trying to identify and look for issues that have occurred. Gremlin, especially when used together with those tools, is designed to help you proactively identify the weaknesses, get ahead of them before they impact the users. So thoughtful, planned experimentation helps you reveal those, especially earlier in the application lifecycle, when the cost of repair is significantly cheaper than if that happens in production.
So I'm going to read this next question verbatim. This is the first time I've seen the downtime cost. My question is there only one way to calculate this? Is there only one way to calculate it, or is it dependent on the kind of business affected? Thanks.
Yeah, I think the simple answer is it always depends, and that's going to be based on many of the factors that the type of market that you're in, the type of customers you're serving, and the types of applications that you're running. So an internal facing application versus an external application, a financial services versus an e-tail, they're going to have broadly different costs associated with them, and also the types of systems and infrastructure that you use, and regulatory controls can all have an impact on the cost of downtime. So there's no one example. The ones that Amy shared early, I think, are good basic examples of how, and it's usually each customer has their own specific way of calculating, measuring the impact.
Well, awesome. Thank you so much for that. I'm going to give our audience another minute or so to ask any more questions they might have. And I'm going to give away those Amazon gift cards I discussed at the top of the hour. So these are for 4 $25 Amazon gift cards. Our first winner is Cindy L. Our second winner is Wayne M. Our third winner is Ain T. And our fourth and final winner is Justin M. So to the 4 of you, congratulations. Keep an eye on your inbox to claim this gift card. And if you don't happen to see that email, please check your spam folder. I'd also like to take this time to remind everyone that the session was recorded. So you should receive an email with a link to access the on-demand recording, but you can also find it living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. It should be waiting for you. So reviewing our questions one last time, I'm not seeing anything else come in. So Don, Ayumi, is there anything that you'd like to leave our audience with before we close out?
I think the only thing I have to say is, it's never too early to test. You're not, your team is ready. I've talked to a lot of different teams that feel like they might not be, as mature as they want to be, but I've also seen people that are a little bit further behind the curve that are able to successfully implement Gremlin or chaos engineering into their practice. So it never hurts to try something new and check it out and, see if it might be a good fit for you.
Yeah, and I would second that. I think that because of the ease of use, the simplicity of the solution, it's something that you could easily try in your own infrastructure and really get an idea and learn some very valuable things about your own systems that you may not have expected. We always find resiliency failures when we go in and work with customers.
Well, Amy and Don, thank you both so much for joining us today, for preparing your respective slideshows and bringing us your demo, sharing your expertise. Thank you so much for being here with us. I would also like to thank Gremlin for sponsoring today's webinar. And of course, I would love to thank our audience. We really appreciate you spending time with us today. We ask for one extra moment to fill out a brief post-webinar survey that should pop up on your screen here in just a moment. But otherwise, we do hope to see you at an upcoming Techstrong Learning workshop or webinar. Everyone, have a great rest of your day. And Don, Ayumi, thank you so much once more.
Yeah, thanks, everyone.
Thank you.